Everyone, today we are going to see about circle theorem. So circle theorem statement is, let f of z be the complex potential. So we know that z is in the form of x plus iy. So the f of z is a complex potential for a flow. And this whatever the flow, the we assume that the complex potential, the function is f of z, and having no rigid boundaries. There is no certain rigid boundaries are available in this complex potential, and such that there are no singularities of the flow within the circle. If there is no rigid boundaries of the complex potential, there will be no singularities for the flow within the circle there will be no singularities. So the circle is modulus of z equal to a. Then, and introducing a solid circular cylinder in modulus of z equal to a into the flow, we are having the flow that is a complex potential of the form f of z having no rigid boundaries. For that, there are also having no singularities of the flow within the circle. In addition to this, we are introducing the solid circular cylinder, that is modulus of z equal to a, into that flow. Then there will be already one complex potential. If you are introducing the solid circular cylinder, means there will be having another complex potential. The both of them combined is given by the new complex velocity potential is w equal to f of z, that is already present, and the new is f bar of z, that is nothing but f of z plus f of a square by z, which is already known as f of z plus f bar of z. So modulus of z greater than or equal to a. So for that, we know that modulus of z equal to a, that is the form. If we taking square on both sides, means modulus of z the whole square equal to a square, z bar equal to a square, z bar equal to a square by z. And we know that z bar is a image of z. So consider this, and z is placed here outside the circle, and the z bar is inverse, so it is present inside the circle of a radius a. Then if z is lies outside, if z lies outside the circle, means the z bar lies inside the circle, and the function also, that means all the singularities of f of z also lies outside the circle, that is modulus of z greater than a. And all the singularities of f of this term will occur inside the circle, that is modulus of z less than a. So the singularities of f of a square by z, that is lies inside the circle. Then if we for example, if z lies outside the circle, f of z also lies outside the circle. If z bar lies inside the circle, f of z bar also lies inside the circle. If we take the inverse, again the inverse, that means z bar, that is nothing but z. So f of a square by z, if we take the inverse, means that will lies outside the circle. So the function f bar of a square by z has no singularity in inside, that will be lies outside the circle. Then consider w equal to, if we are know that w equal to f of z plus f bar of z, has f of z also lies outside the circle, and f bar of z also lies outside the circle, so has the same singularities outside the region, which means the function f of z and f of z plus f bar of a square by z both have the same singularities, and that lies outside the region. Therefore the cylinder are satisfied by this condition in the presence of, so the cylinder condition is satisfied in the presence of the cylinder. Hope you all understand, and thank you.